Today's learning target is I can add and subtract fractions.
Today we're going to be taking a look at adding and subtracting fractions with like denominators. Now if you look down here, I have two examples where I'm showing a fraction. Okay, so let's look at this one right here. So this fraction I've written as 5/8. Now just a reminder what that means. The bottom number is called the denominator. The denominator tells us how many parts the whole is split into. So we can see in this one, the whole circle is right here, and it's split up into 8 different parts. Over in this one, and here's the whole circle, and we can see it's split into 4 parts. The top number in the fraction is called the numerator. And the numerator tells us how many parts of the whole we have. Okay, so in this case, we see the numerator is 5, and I can see there are 5 equal parts that are shaded in here. So we have 5/8. Here's 2 equal parts out of 4, so it's 2/4. Now when we're going to add or subtract fractions, it's important that our denominators are the same. So in this example right here, I'm not ready to add these two or subtract these two fractions because the denominators are different. However, if I had this over here, and now I have 2/4, and let's say I wanted to add another 2/4. Now take a look and we can see the denominators are the same. And when they're the same, I'm just taking a look up here and I'm saying, okay, I'm taking 2/4, here's 1, 2, and I'm going to add these 2/4 to that. So if I put these 2/4 right here over here, I would have a total of 4/4. Or another way to write that would be 1 whole. So in some of the problems today, you're going to be ready to add or subtract right off the bat because the denominators will be the same, just like we have here, 5/9 plus 2/9. So my denominators are the same. I'm ready to solve this. Now right off the bat, when I add or subtract and my denominators are the same, I know that my answer is going to have that same denominator right here. So right off the bat, I can look at this and say, I know I'm dealing with ninths. Okay? Some people make the mistake and they add these two. Okay? And they say, oh, my answer's got to be 18ths. No, I'm putting 5/9 together with 2/9. So what I do is I add the 5 and the 2, and that gives me 7/9. A real world example, we could say something like this. If you flipped over 5 out of 9 cards, that would be 5/9, 5 out of the 9. And then you flipped over 2 more of those 9 cards. You've now flipped over 7 out of 9 total cards. Subtraction is going to work the same way. If I have denominators that are the same, I'm ready to go. Okay, so I know my answer here is going to be tenths. I have 9/10, and I'm taking away 1/10. Okay, so I have 9 of those tenths. I'm taking one of them away, one of those tenths. I now have 8, and I'm still dealing with tenths, so I have 8/10. Now, in this one, I notice I can simplify. Okay, remember, when we simplify, we get this fraction to a fraction that's going to be the same, but smaller numbers. So to do that, I know from previous years, I can divide the numerator and denominator by the same number. So if I look at this, I can divide both these by 2 because they're both even. Okay, and if I do that, I get 4/5. And I know that's in simplest form because the only number I could divide both of these by would be 1. Sometimes you'll be asked to add or subtract fractions where the denominators are different, like they are here. Those are called unlike fractions. When I have unlike fractions, my goal is to get both of the denominators the same. Okay, and so what I'm going to do here is I look at these two, and I see this one right here. I could get this 4, and I could multiply that and make that 8. Okay, just like I have an 8 over here. That would make my denominators the same. So here's how I show that. I'm going to put a times by 2 over here. But if I do that, I have to make this fraction equivalent or equal. So if I only multiply the denominator, the bottom number, it becomes 3/8, and that's different than 3/4. But if I multiply the numerator also by 2, Okay, now I've created a fraction that's equivalent or equal. It's 2 times bigger, and it's 6/8. So now I can add 7/8 plus 6/8, which gives me 13/8. Now I notice something unique about my answer. My numerator right here is bigger than my denominator. This is called an improper fraction, when the numerator is bigger than the denominator. And what it means is I have more than one whole. Right? So over here I've shown, here's a picture of a whole circle. It's split up into 8 parts. Okay? This answer is telling me I have 13/8. So that means I have 8/8 right here, which makes the whole, and then 9/8, 10/8, 11, 12, 13/8 right there. So this improper fraction is really 1 whole and 5/8. Now you probably don't want to have to draw pictures like this when you have an improper fraction. So I'm going to show you a way to do this using division, where we can figure out what the answer would be as a mixed number like this. So we're going to do 13 divided by 8, similar to what we did when we were figuring out what the fraction is as a decimal. Okay, so I set it up, and I know that 13 divided by 8 looks like this, right? The bottom number is always on the outside. Now I do my division. I know 8 goes into 13 one time. 1 times 8 is 8, and now I subtract, okay, and that gives me 5. Now, normally when we did this with finding decimals, we put a decimal here and a 0. When we do this, we just want the remainder answer. So 1 with a remainder of 5. And here's what this means. The 1 is how many holes we have. So we have 1 hole. The remainder right here tells us what is the numerator going to be. So it's going to be 5, and we know that we're dealing with eighths. That's what we were dividing by. So it would be 1 and 5/8. Now the last type of problem that you'll see today looks like this, where I notice my denominators are not the same, and I can't multiply one of these denominators by something to get the other one. Can't times 8 by anything to get 12, or 12 by anything to get 8. When that's the case, I want to find the least common multiple of the denominators that I have. So I've listed my multiples here for 8 and 12, and I see that 24 is the smallest or the least common multiple. So I want to get both of my denominators to be 24. So when I do this, I see, okay, I have to take 8 times 3 to get 24. And if I do that to the denominator, I have to do the same to the numerator. And then over here for the 12, I have to get 12 to 24, and I do that by timesing it by 2. And if I do that to the denominator, I have to do that to the numerator. Now I put the equivalent fractions just down below. I rewrite them. That's what you'll do today. So this becomes 22/24. Okay, so I write that. And I'm going to take away this equivalent fraction, becomes 9/24. Now my denominators are the same, and I can just subtract my numerators. So 22 minus 9 gives me 13, and I'm dealing with 24ths, and that is in simplest form, so there's my answer.
And that's how you add and subtract fractions.